Hello and welcome to this Tech Skills training presentation. In this video, we are going to go through the steps required to measure the subcooling in a refrigeration or air conditioning system. By measuring the subcooling of a system, you can determine if the refrigerant leaving the condenser is below the saturation temperature for the particular refrigerant being used. If the refrigerant is below its saturation temperature for its relative pressure, this will indicate that the refrigerant is in a liquid state with no vapour present. Measuring the subcooling of a system is also an important part of analysing a system's performance. The two types of subcooling are the condenser subcooling and the total subcooling. The tools required are a refrigerant gauge, suitable for measuring the high side pressure in the system, a thermometer with a sensor that will allow for accurate pipe temperature measurement, a pressure temperature chart suitable for the refrigerant used in the system, as well as your standard industry hand tools. To measure the condenser subcooling of a system, you will need to measure the liquid line pressure immediately after the condenser. Also, measure the temperature of the liquid line, ideally 150 millimeters from the outlet of the condenser. Fit a high-pressure refrigerant gauge on the access point at the outlet of the condenser. To measure the condenser superheat, ensure that the refrigerant gauge is fitted on the condenser side of any line fittings, such as filter dryers, strainers, and liquid subcooling heat exchangers. Ensure that the system has run long enough for the temperatures and pressures to stabilise. To measure the total subcooling of a system, the temperature and pressure measurements are taken just before the inlet of the expansion device. Compared to the condenser subcooling, the total subcooling measurement can be affected by pressure drop, which will vary with the length and quality of bends in the liquid line, restrictions in the filter dryer caused by moisture or partial blockages, as well as temperature changes caused by liquid subcooling heat exchangers. To calculate the subcooling, take the liquid line pressure and cross-reference it with the temperature on the pressure temperature chart. Then measure the liquid line temperature. Deduct this from the temperature determined from the pressure temperature conversion chart. This will equal the subcooling at that point in the system. It is best to refer to the manufacturer's literature to find out the optimal amount of subcooling required for a particular system. However, it is often between 5 and 8 Kelvin. The main ways to alter the subcooling in a system is to vary the airflow on an air-cooled condenser or water flow on a water-cooled condenser. The flow of air or water across the condenser is often controlled by a controller that reads the high side pressure. This pressure control is set to cycle or vary the speed of the condenser fan or condenser pump to manage the amount of subcooling. Increasing or decreasing the quality of refrigerant in the system will also affect the amount of subcooling. For more information on any of the TechSkills products, please visit our website on www.techskills.com.au or send an email to solutions@techskills.com.au.